This guys. Alright, this is a short introduction to my new project here. Calling it the half-ton amphibious tractor. Basically, I started with my specs here. I got, just like any military contract, you gotta have your military specs to start the engineering project. 1,000-pound payload capacity, land and sea. So I figured 3 axles would be enough if I used some big trailer tires. Under 6.5 feet wide. Greater than 14-inch ground clearance, so she won't belly in soft ground, and then less than 2 psi ground pressure for good marginal terrain capability. Less than 3,000 pound empty weight, because anything more would be a tank. Use common automotive parts for reliability. That's kind of a big ticket item right there. It's kind of new for me. I'm used to using small lawnmower parts, so this will be new. Brake differential steering, which I intend to use disc brakes with tandem calipers. I'll probably do some testing too to see if you can get by with just one caliper, but that'll be later on. An adjustable width tub frame, because when I first started this project I had no idea what rear axle I was going to use, so what I did is I designed the tub to be split. It's going to be a split tub, so that way you can decrease or increase the width by plus or minus 4 inches. Plate steel frame, so it's going to be fairly easy to fabricate. 3 axles, walking is going to have a tandem axle walking beam with a trailing idler, a leading drive sprocket, and no support rollers. Trailer tires as the wheels, like I said, and then steel rims for the idlers and sprockets. And then for the general design concepts for the undercarriage, I'm figuring to using the Russian tube type track with conveyor belting, and then the same Russian sprocket and idler design. Down here is just a bunch of junk. I was saying, hey, if this thing works pretty good, I wonder if I could sell it. This is comparing to like Argos, Max ATVs, Hydro Tracks, Land Tamers, and Light Tracks. I wouldn't call it a Marsh Master. That thing only goes like 4 miles an hour, so I'm not going to count that in here. But I guess, as you can see, the disadvantages is a lot bigger than the advantages. I guess the biggest one would be you'll get if I provided a steel kit, it'd be around $3,000 to $4,000, and then obviously it'd be another, probably another $3,000, $4,000 to tack onto that to get it all finalized. Because I'd just be supplying the steel conveyor belt fasteners, that junk. Everything else the customer would provide, but that's kind of beyond the scope of this video here. So yeah, I plugged her in, and this is kind of why I sketched up. As you can tell, if you've ever been on the Russian part of the internets, this is pretty familiar looking. It looks pretty much exactly like a common Russian amphibious tracked vehicle that they make themselves over there. Just because it's kind of interesting, there's no domestic market for Argos in Russia, so they kind of have to build their own, which I thought was cool. Yep, 3 axles, tandem walking beam in the front, rigid rear axle in the rear here. Trailing idler. This tensioner, I'm not using that design, just so you know. And then this is an open slotted, so you can, once you build this frame up, you can shove your differential in there and then you can cap it off and all that jazz. That's your drive sprocket right there. And some work numbers. And of course the designation half-ton Amtrac. Donald Roebling would be proud. But yeah, after that I kind of put it in the computer here, using that hex nut to hold this down in the wind. Basically, I got my general specs for my undercarriage, and then that way that would lay out my whole entire frame once you understand what you want here. Some of the key features. So my big thing here, as you can tell, only got about 64 inches of ground contact. I know some of you guys will be probably worried, hey, it's not gonna be able to climb shit. Well, here's the deal. My intention is I'd rather have maneuverability than hill climbing ability, at least in this part of the region. I'm in northeast Iowa. Sure, we have lots of hills, but I'd rather be able to turn the damn thing than just to go up straight up a damn hill. This ain't a hill climber, so we'll see how it goes though. This is my drive sprocket trailing idler right here. As you can tell, it's a pretty big machine. 130 inches in length, and it's going to be 6.5 feet wide. It's going to have 20-inch wide tracks, so that leaves me, at least with my automotive gauge, which is over there. I got a 59 3/4 inch axle gauge, which is pretty much center to center of rim, which leaves me a 36 inch tub width, which is plenty for what I'm using. I'm using a Toyota 20R coupled to a stock 4-speed, which will then be coupled to another 4-speed for increased gear reduction. And that'll be my turning system over there. As you can tell, I got the tracks done. But anyways, moving on. Yep, like I said, then I put in the computer once again. I built the frame up in 3D. As you can see, all plate steel design, so that makes it pretty easy to fabricate, in my opinion. You don't have to mess around with measuring squareness and flatness, because in theory everything should be flat and square when it comes off the press brake, but and all of it's going to be plasma cut too. I'm just farming it out at work. They got a plasma table and a press brake, so that'll all be fabricated beforehand. 3/16 glasses, front glasses plate, 1/8 inch all around the bottom tub here, and then the upper superstructure right here, it's going to be all 12 gauge steel. This is kind of the tensioner Russian inspiration. Basically, it's just going to be sliding on a tube there. That's what these are. These are your slider tubes. You got your rigid rear axle with your drop plate where your spindle is going to be welded. And then you got your walking beam cross tube right here where your walking beam spindle will be welded. This goddamn wind would just stop it. But yeah, all gusseted up. It's going to be a pretty heavy machine. I'm estimating, for me, at least with my powertrain, 2,800 pounds empty. So it's going to be quite the beast. But the nice thing is, fully loaded at 3,800 pounds, I still got about 10 inches of freeboard, which in calm inland seas is good enough for me. I would not want to take this thing out on the surf, whether it be the Atlantic or the Pacific or the Gulf. Let's see if I got some other pictures here. Here you go. It's a pretty decent one right there. So we'll see how she goes. Actually, here's a pretty good picture of the, you see that seam there? I don't know if you can see that or not. That's where the tub is split. So that way you can go plus 4 inches or minus 4 inches. So that way it'll accommodate pretty much, in my opinion, any automotive axle out there on the market, rigid rear axle. So I thought that would be pretty slick, at least in my opinion. But yeah, that's basically the general summary of this project. As you can see, I got the tracks done, like I said, and I got steel all ready to go. The only steel I don't have is all the plate steel, because at work they've been pretty busy and they kind of put my project on the back burner. So I also got all of my other components as well. So I hope to have it done, I want to say before mid-November, but we'll have to see about that. That's it for now.